Yeah, you know how every time I do a video working on someone's radio, I say I'm done. I'm not going to work on people's radios anymore. Well, guess what? I'm working on someone's radio. Hey all, welcome back. It's been a while. I've got a couple of radios to fix. One I'm not going to bother filming because it's a Columbus 26P sitting down on the floor there. And we've done one of those already, so if you want to see that, go back and watch the one I've already done, because I wouldn't imagine this one's going to be any different. But this one I am going to film. This is a big Rolls. You can see from these photos that it actually takes up a fair whack of my bench. It looks bloody good, actually. They've done a really nice job. So the cabinet's all been done up, but the radio itself apparently doesn't work, or scratchy volume control. I need to check the email from him and just double check that. Yeah, so I'll give it a once over. I imagine it's going to need new capacitors, power supply checked out. The power cord is frayed, so that's going to have to be replaced. These sets were actually really well built. I've done a smaller Rolls a while back, which I never filmed. It was before I'd started filming, and I've got some photos of it here. You can kind of see before and after shots of that. It was a huge mess. I'm hoping this is going to be nothing like that. Just briefly looking in the back, it shouldn't be. So yeah, this is going to be a case of pull it out, run it up, double check it, and then guess who? Alright, so the power cord is damaged. The outer sheath is broken through in quite a few places, but the inner sheath is fine. There are no conductors showing, so it's going to be okay for a test, but I'm not returning it like this. Is completely unacceptable from a safety point of view, so we'll be replacing that. But for now, we're going to go through the dim bulb tester. And we'll just see what we get. Alright, we're via bulb. It is on, there's a big flare up. 6 valves plus I, so 7 valves it's trying to heat. It is a little brighter than I'd want to see, but it's not bad. Magic Eye is dead, so I'll have to talk to him and see if he wants a new Magic Eye fitted. I do have a few spares, but not a lot. Well, that tuning's very, very stiff. I've got no volume that I can hear. Right, just starting to come now, just getting a bit of a crackle. There's just a short aerial on it, but okay, that's better. Tuning is slipping as well.
Busy tradie, shop owner or farmer looking to hire staff? It's time to consider Trading Jobs. With relevant job hunters browsing daily and over 16,000 job searches every hour. So post your job on Trading.
I think that's supposed to be the band switch. No, that's the band switch there. We've actually got lights on the things for the bands, so I'll have to double check that. I need to get the schematic out and have a look. I haven't done that yet, but actually this is not horrible for what I'd expect. That's a fairly loud station, so it should be a bit louder than it is. So it's not working perfectly. I would expect that to come through a lot less staticky than it is, even though we're out here in the country. It is a 6 valve set. So it's working, and that's good. There is no on off. I would have thought maybe one of these would be on off. The knobs are really loose, as you can see, which is fine. I've got to take them off anyway, but yeah, working. let's make it not working and then make it working better. Alright, so here we are. It's a model BCR. BCR basically means it's a model BC. Radio Limited had a range of different brands that they manufactured for, and they did to a certain degree, like the serial plates would carry the code for that brand. So BCR, R is for Rolls, it's a model BC chassis. And so there'd be a BCS in Skyscraper, there'd be a BCU for Ultimate, Courier would be BCC, but I've seen various brands with what you would think, if you believed that code was hard and fast, to be the wrong chassis in them. And if I'd only seen one, I'd think, well, someone's just got a replacement chassis from somewhere because it rusted out, but you actually see it all the time. So I think they did runs of chassis and then just used whatever wherever. This is a BCR. R is the code most often found in Rolls. That makes sense. So it shouldn't be any different to any other BC whatever. Alright, so I know I said that this was a 6-valve set, and I'm going to dig my hole deeper here and say it kind of is. Clearly I can't count. It's a 7-valve plus Magic Eye. There was an extra valve just here which I completely missed when I was looking at it. I was going to say it's really dusty, and I couldn't see it through the dust, but it is a 7-valve, but as you can possibly see from the circuit, if you can follow it, Radio Limited drew their circuits in a really weird way. And I find these quite difficult to read, but they use 6K7s everywhere, so we should see a pile of 6K7s, and then there's a 6C5 for the oscillator. So the oscillator is separate from the mixer, so it's got what it calls a modulator, which the oscillator feeds into. So yeah, this is the RF side of the radio, and you can see the 6K7, it's fed from the aerial, so that's our RF. And our RF coils. That then feeds through to this 6K7, which is what they refer to as their modulator, and down here is a 6C5, which is the oscillator. So the oscillator is basically being fed into this modulator, which is then fed through here to the first IF. And then our third 6K7, which is the IF amp, second IF, and then on to the 6Q7, our first audio, down to the 6F6 output. And it's 6G5, which same as a 6U5. Like I said, I should have one of those that goes well enough to actually make the eye work again, but I don't like to part with these not good working ones. I have enough of my own sets that need Magic Eyes that I don't really like to sell them. So if I do sell good ones, I tend to sell them at a premium in the hope that people won't buy them. So that's the deal basically. We've got an 80 rectifier, pretty standard. One of the two 10 mic capacitors is not grounded, so I need to make sure that they're not boogered up. And it looks like actually that switch that made things quiet, it looks like it's a sensitivity switch, which would make sense because it did drop the sensitivity, and it appears to be so off the cathode through a 200 ohm resistor through a 2K resistor. So this W is ohms, so that'll be a 1 meg resistor, I think. That'll be a 2 meg resistor, I think. 50,000, so that'll be a 50k. Anyway, 2k resistor or 2000 ohms with a sensitivity switch cutting that out. So it's just changing the biasing of this RF. So I imagine cutting that in is akin to turning a 6-valve set into a 5-valve or near enough to it. Clearly we don't need that on the set out here, but the gentleman that owns this lives in town, so you know he may find that useful. So we'll make sure that is working correctly. It certainly seems to be. Other than that, it's just going to be a case of I'm going to start here and replace these two 10 microfarad capacitors. We'll double check this voltage divider here, and then we'll just start replacing capacitors as we go through. All the paper caps will be gone because they are no good, and the power cord will also be gone because it is no good. Then we'll start spot checking resistors and test it. Alright, enough waffle. Let's get into it. Okay, let's have a look underneath. Might just take that off there so we don't end up squishing it. So 6U5, not a 6G5, so that's been replaced at some point, which is not surprising. These Magic Eyes have a lifespan of about 1,000 hours, roughly, give or take. Well, that's the generally accepted lifespan of one of these before the phosphor wears out or boils off or whatever it does. And then basically all it's doing is sucking current from your transformer, because they don't do anything else in the circuit typically. They're just there to indicate AGC voltage, really, I think, and that is displayed as a green eye. This one appears to be dead, so it can go back in or it can be replaced. I'll talk to them and we'll find out what we're doing there. Now we should be able to flip this up without damaging anything. These are not light chassis. Not light at all. Oh. Alright, so at this point things look pretty good. I'd say it's had repairs at some point, and it's definitely had repairs. We've got these Dublier plastic caps. These will still be paper caps, they're just sealed in plastic rather than wax. I'll still be replacing them because I don't trust them. We've got what looks like some original capacitors in here. Lots of these dog bones. Now I find that these dog bones are generally out of spec. These ones with the lines on them, they don't seem to have stood the test of time, which is fine. I'm not necessarily expecting them to, given that they are many years old. This has had a resistor replaced, so it's possible that the last serviceman in here did check the resistors, so we may get lucky. But then the last serviceman in here did not replace all the capacitors, just the ones that needed replaced. A Riken Chemical made in Japan cap. I imagine that's probably 80s at best. These ones probably, I don't know, 60s. So yeah, plenty to do. Guess who? Okay, I'll just start over in this corner here, just because I can. It's got a bit rusty, these ones. Alright, what do we got? That's a 0.5 at 400. 0.5 is easy, that we can do. So this one is a 474, and how you work this out, for those who are interested, just grab a bit of paper. This will do. This is actually my jukebox preamp circuit. Don't even remember if I videoed that or if I just made it. But for now, not what we want to see. What we want to see is, you can tell 474 is the same as 47 and 4 zeros. So it's 470,000 picofarads or 470 nanofarads. So that is in picofarads. So you take 3 off and it's now in nanofarads, and then you can take 3 off and it's in microfarads. So 0.47 microfarads is basically the same as 0.5 microfarads. So the trick is to remember that it's in picofarads. You go picofarads, nanofarads, microfarads. If you can't remember that, write it down. If you can't write it down and remember it or figure it out, just use an online calculator of some sort. I don't use them, so I don't know of any. I'm sure you'll find a good one. If you do find a good one, stick it down in the comments and then everyone can enjoy it. But yeah, 474 is basically a 0.5 microfarad, so that's what we took out. So that's a 400 volt version. That's a 630 volt version in modern money. So we're going to save a wee bit of weight. It's going to be much lighter to put back in the case when we're done. Alright, so that came from down here. and up to the earth tag. The earth tags, I really like the earth tags in these sets. I don't know how clearly you'll see any of them. There's one here, there's one here, here, one on the back. There's a few of them around. They're basically little metal discs, probably nickel plated, but instead of just being a disc, they're shaped like a dinner plate. So they come up at the edges, they're spot welded in the middle, and then because they're lifted up at the edges, they're not heat sinking into the main chassis, and you can actually solder to them quite easily. So they're a nice wee thing. Don't forget when you're doing this to keep the writing on the cap face up, so that the next person to come in and have to replace these, probably not for 20 or 30 years I would hope, can see what the value is and easily replace it themselves. I don't know where this 0.5 is in circuit, and to be honest I don't actually care. Hi bud, I expect it's on a power supply line somewhere. Got a 0.25, I wonder if that's it.
One eternity later.
There's the two IFs, so that's going to be this 6K7 here. 0.5, oh there it is. There you go, it's right there. I'm going to use my dad's old roller solder 5 on this one. I do like nice solder. That's hooked in there. Probably use pliers instead so I don't end up cutting it off by mistake. It's good. Find that hole. Where is that hole? Come on, hole. There we go. All right. That dealt with. Just get that wire away from that yellow wire there. There's a lot of dust bunnies in here, but not much in the way of spider webs. Okay, so there's our 0.25 that we saw. That's the power supply one. I'll need to get that out, because that'll be NFG. .25, 400 volt. So just as before, this is a 224, so same deal, 22 and then 4 zeros, so 220 nanofarad, and that's 0.22 microfarads, which is the modern near equivalent to a 0.25. So that can go in there. It's not going to reach, I don't think. No, it's close, but it's not close enough. What I could do, because we've got an unused tab here, I could just run it to there and then run a wire down to earth. I think that's probably what I'm going to do. Okay, let's see what the chances are I can clean this tab up. It's pretty grubby. I may actually need a bit of a sand. see how we go soldering to that. I don't like my chances just looking at it, but you never know. We'll crank the iron up a few notches and we'll see what happens. It'll be fine. Get that clean before I melt it too, because that's all very dusty. Ow! That's hot. Who knew? I'll see if I can get that old tail out. Again. Alright, let's clean that hole up. Alright, that's in there. Get a little bit of wire. There we go. Alright. That's not super pretty, that, but that will do the job. Okay, what else have we got? This is going to be probably going to be a cathode bypass, I would think. I had to guess, and I don't have to guess, so I probably shouldn't. 25 mic, 25 volt, 25 mic, first audio, connected to, right, pin 8, which is probably the cathode, and what did I say? Cathode, so 6Q7 cathode, 6Q7, pin 8 is the cathode, yep. So 25 mic and a 2K resistor across it. Should be 2K. Probably not a lot of point trying to measure that, particularly if this is leaky, but let's do it anyway, and then we'll take it out and measure it properly. Yeah, 2.5, that's not too bad, I suppose. Take it out. Maybe that cap's not very leaky at all. At low voltage anyway. Let's grab a new one. So this replaces this. This is a 25 volt, 25 mic. This is a 22 mic, 50 volt. Alright, so 2.5K, that's probably fine. I'm not going to have a 2K resistor to replace it with. I'll have 1K8 or 2K2, and given this is 2K4, I don't actually think I'm going to replace this resistor. It's not out of spec enough, so these would be probably a 20% resistor, you know, 2K, I mean, it is just over 2.4, so it's slightly out of spec, but it's pretty close, and not enough that it's going to cause any great issues, I don't think. We'll check the voltage. So we should have 1.4 volts at the cathode when we're done, according to the schematic, so it's handy that it's actually got that measurement there. I'm going to leave this in for now. We'll see how it looks when we're all done. So what I'm going to need to do is tidy up these legs enough that I can actually solder to them. That's going to be the tricky bit, I think. And then I'll just put a new cap across this, take the old cap out. Sometimes I wonder if isopropyl alcohol wouldn't be better replaced with muriatic acid, but it feels like a step too far. It would certainly clean the legs up though. You know, that's taken solder really nicely. This side not so much. Well, okay, don't... I shake enough as it is, but when you put your wrist across a hard edge like that, your pulse causes a bit of a bounce as well. So don't forget to check the polarity of these before you pull them out. I know that this will be negative to ground, so negative's that stripe. Done, and then we'll just put that back on that tag. So worked our way across to here. Now what we're looking at here, two caps in parallel. Not done so that you can actually read them. Pain in the ass. Two 6 microfarad caps in parallel, so clearly didn't have any 10s, had a couple of 6s, put them in parallel, job done. So the tab they're soldered to on the negative side goes to the speaker terminal, and so it's going to be the first filter cap. So it's got a 12 in there at the moment. One side to the main HT, which is going to be this one on this side, I guess. I can trace that and confirm. The other side to the field coil. That side does have a wire going to the speaker terminal. So we'll get that out, because them's old capacitors. Replacements, but old. So I know they're replacements because the originals should have been in these two holes here. If you do disconnect these, leave them in. Some people actually prefer to have the chassis looking complete from above. It also stops mice getting in, although this chassis has holes in other places that a determined mouse would get in anyway. But a mouse is just going to go straight through a hole like that. So if you do have rodents, they're going to get into your chassis and start eating things, which is not ideal. Or worse, they're going to get in there while it's running because it's nice and warm. And then there's going to be an earth-shattering kaboom.
Where's the kaboom? There was supposed to be an earth-shattering kaboom.
And you don't want that. It's better if you don't have an earth-shattering kaboom. Okay, so that goes to there. The other side of there comes out here, and it goes off to the start of our cam dome resistor, which you can't see, but trust me, there's a very long cam dome resistor under here. We'll need to check that at some point as well. And yeah, so that should also be the center tap of the transformer, and the only thing that should go to it is the field coil and the capacitor, which is what we got. Good. Enough waffle. Alright, don't hold on to that with fingies. Alright, so I can do 10, I can do 15, I can do 22. The 80 will be happy with any of those, 15 will be fine. So these are 15 500 volt Rubicons. I tend to only buy Nishikon or Rubicon. Negative side goes to the field coil over there. This is HT positive. There you go, something like that. Set it off. I don't think there's holes in those tabs that I'm easily going to get wires through, but we'll give it a go. That reminds me of a bottle of Johnny Walker. Alright, that's nicely out of the way. I have to get the neutral wire of my new mains cord under there at some point. So this should be a 47 mic. That's a bit high. That one is to ground and goes to, this should be the output bottle 6F6. Pin 1, 2, 3, pin 4. What's pin 4? Screen? Should be the screen. 6F6. Pin 4 is the screen. 6F6. Here's our screen, which is connected to HT. So that's the other cap. Someone's replaced a 10 with a 47. You can go higher on the second one. The result is slightly better smoothing, but typically also a slightly higher HT because of it. The more you smooth the ripples across the top of the rectified AC, the closer you take that average or RMS voltage to the peak. Before I do it, I'm going to check this resistor because I've got to take that out. I'd rather take it out now. So 12.8 is a 10k resistor, so 12.8. Again, it's not too bad. It's near enough to spec. Okay, let's get this out. I'm not going to replace it with such a high value. And I think, because I'm going to move this, this will be out of the way. I think I'm going to put it here, which is a couple of wire hops back, so the red wire that comes off runs up to here, then it jumps down to here, then it jumps back to the transformer. So if I go off here, I can reach across to here. This is in the way, but it won't be shortly because I'll replace that with 0.05 by the looks of the schematic. So we've got a really big candome resistor that runs right down here. This terminal is earth, and if you look on the schematic, it's that terminal there that's earthed, and we've got a 0.05 between there and there. They've gone from there down to this earth lug because the capacitors are just too big to jump across here. I'm going to put a 0.05 from there to there, which is going to give me a bit of clear space here. It's going to get rid of this, and then I can put my 20... Well, you didn't get to see me install it because the camera shut off. Anyway, I've emptied the card, and while I was there I just made myself a quick reference sheet of where each of the valves are and what the layout is, but then I got it round the wrong way to what I'm working, so it's upside down. But I can still see where my valves are now, which is going to be helpful, probably, maybe. Anyway, at this stage, where did I get to? So I replaced the capacitor that was here. That was a 0.25. Circuit says it's a 0.05. I've replaced it with a 0.25 just cause. And now I need to put in my second cap. And I'm going to go from here, and then I can go to the earth point here, so I can just run across here, that'll be fine. There we go. A little bit untidy there. That's really doing the splits, that one. Okay, so that's our power supply taken care of. Our power supply cap's done. We've got some RF caps over here. These don't get as much of a bashing, so they don't look melted. They're getting replaced anyway. These ones, yeah, I wish I had a cap tester to test those ones and just see how they are. They haven't been put in very tidily. This one it's been looped through the tag, but it's just been done in a big circle, so I think the only place it's actually properly soldered is probably just the edge of the loop where it comes up on the edge of that tag. Interesting to see how yeah, shouldn't be able to do that. Okay guys, thanks for watching. I'm going to leave it here and I'll come back to these other caps when I have a moment, and then I think probably we'll have a third part as well where I'll do the alignment and just make sure everything's going as well as it should. And look out for part 2, it shouldn't be too far away, and I'll catch you on the next one. Thanks for watching.